This video is part of our series on making 5-point stars, and this video concentrates on the design concepts associated with these stars. For example, I may want to design a star of a particular diameter contained within a border of a particular diameter. In this coffee mug, it had cracks and holes in the bottom, so I drilled a 2.5-inch diameter hole. And into that, I need to put a star that's slightly less than 2.5 inches in diameter. And I want to contain that star in a border that's slightly greater than 2.5-inch diameter. So I can turn that border down until it fits tightly into that hole. There's a couple of ways to design that star. Here I can imagine drawing a scale model of the star, and then from that model and this one equation, I can determine the design parameters that teach me how to build that laminated blank. So this lower part of the diagram is a representation of that laminated blank. And everything I need to know about this blank can be obtained from this picture, a scale drawing of what I want to make. That'll be one thing we talk about. I can also take this picture and convert that into 4 equations. That also tells me everything I need to know about this laminated blank. In addition to thinking about the size of the star, I can think about adding bandings, modifying the color of the star, and I can also think about modifying the border of the star, and that'll be another set of embellishments that we can talk about. But again, ultimately, we're talking about designing this laminated blank. So this is the blank I used to make the simple star. The first question I have to ask is, how long does this board need to be? And the simplest solution is to measure the width of this central board and call that H. Then 9H is going to be the bare minimum board length that we can use. So these two lines represent the last kerf in the cut that freed up the last, or the 10th segment for my star. And this board length is marked here based on this equation. And you can see I have very little slop here. So this is a bare minimum. Okay. Typically what I do is add to this bare minimum a little bit of extra so that I can get 2 more segments. And then I add a little bit more just in case I make a mistake or there's a knot or imperfection somewhere in the board. It may turn out I just want to make a star. I don't care how big it is. I don't want to add embellishments. And in that case, all I have to do is build this laminated blank with the outside 2 boards having the same width, and this inner board having some width and a length that's 9 times the width of this inner board. And that's all the design work I have to do. I don't need the picture. I don't need the math. I just need this approximation. That will let me make a star of some size, and I'm guaranteed my board will be long enough. But I'll say it again, this is a bare minimum. We really need to add extra to this length. Now, in order to make a star of a particular diameter in a background of a particular diameter, I have to be able to make that laminated board of a particular size. So this lower part of the picture represents that laminated blank. I need to know the width of the outer 2 boards. I need to know the width of the central board, and I also need to know the board length. And this number B is useful because if I add B to the board length, I pick up 2 more segments. Okay. So to fully design this star, I need to know W, H, and B And from that, I can calculate the board length, and that's everything I need to know about that laminated blank. Once I have the laminated board, I can form the star that I want. One way to get that information is to draw a scale picture of the star and border that I want to make. So let's say I want a 10-inch diameter star and a 14-inch diameter background. I set my compass to 5 inches and draw a circle. I set my compass to 7 inches and draw a circle. Then I draw a line through the center from outside circle to outside circle. And now I want to divide that into 5 parts. And I can do that using this equation. The step size will be 1.176 times 7, the outside radius, the radius of the outside circle. And that's about 8 1/4. I'll set my compass to 8 1/4 and I step to here, then here, then here, then here. And then I step back to the beginning just to see how close I came. And if everything looks good, then I draw 5 of these lines. And that divides these circles into 10 segments. Okay. Then I move to the center circle and I draw my star. So now I have created a scale model of the star and border that I want to make. And now I need to extract these numbers. And you'll recall the first thing I do is cut the segments at 54 degrees. And here's a paper model of that. And it sits in my laminated board in this manner. So I need to discover W, H, and B from this diagram. And I can do that by extending this radial line up past the circle. Then I extend this line up past the circle. And I take this line and draw it parallel to where it just touches the outer edge of the circle. And it intersects these 2 lines. This distance is B. I find the midpoint and draw this line, and that distance is H. I draw this line until it intersects this radial line, and that distance is W. And that tells me everything I need to know to form this laminated board. Now this is labor intensive because if I want a 14-inch diameter border, 10-inch star and a 14-inch diameter border, I draw this picture. If I want a 2.5-inch diameter star and a 2.5-inch diameter border, I have to draw another picture. And every time I change sizes, I have to draw a picture. So this is rather labor intensive. There's no math involved, no equations except this one, but it is labor intensive. I can take this picture and convert that to a series of equations, and I can set those equations up so that all I need to know is the radius of the star and the radius of the background, and that tells me everything I need. Okay. And here I calculate the board length, and the +2 represents 11 curves at an 1/8 inch per curve, and then I just rounded that up to 2. This is more exact than 9H. This depends upon the radius of the star, the radius of the background. Here are some sample calculations. If I plug little r is 5 and big R is 7 into these equations, these are the numbers I get. And these are exactly the numbers I measure off of here. So W is 1.55, and I pick this up, and W is a little bit more than 1.5 inches. H is 4.41, and I get 4 3/8. For B, I get 6 3/8, as opposed to 6.41. The board length is 38 inches and a little bit. I would always round that up to 40 inches minimum. Then I would add at least B so that I can get 2 more segments. And then I would add on something this big, I would add another 6 or 8 inches just to be safe. Whether I used a picture or these equations, it doesn't matter. All I have to do is determine these 3 numbers and the board length, and I can fully define that laminated blank. Now it turns out that these equations are really useful because I often oversize the radius by 1/16 of an inch, and I'll oversize the radius of the star by 1/16 of an inch, and the radius of the background by 1/8 or maybe even 1/4 of an inch. In the final cut, I come up with these segments, and this distance is the radius of the star. And if I oversize that distance, I can come back and trim just a little bit off until I get the radius that I want. That can be very useful, especially if these chip. Quite often this point is so pointed, this end is so pointed that the wood will chip when I cut it. And by oversizing by a little bit, I get to come back and trim a little bit, and that removes part of that chipping at the edge. The radius of the border is along this line. And normally what I do is just turn that down to the desired size when I have it on the lathe. These are easy to use. I can easily oversize everything and trim at the end. This is my preferred way to do it. Now that we know the relationship between the star and the nature of the laminated board, we can start exploring some design possibilities. I guess the simplest thing is to take one of these simple stars, glue a log on top of it, and just turn a bowl out of that. We don't have to design the size of the star. All we have to do is make sure that this joint is flat, and we get a nice tight fit, and you can come up with an interesting object from there. Here we can take a small, rather uninteresting object, drill a hole in it, and design a star to fit inside there and turn it into something a little more interesting. We can continue that concept, and here I've added 13 stars of a definite outside diameter around this wide rim bowl. There's another variation you can make on this. If you use standard segmented turning techniques to calculate what size segments you need, you can oversize the border of your blank and cut those segments and put 13 stars in a segmented ring instead of drilling the holes. Another variation on top of that is to take these stars and put them in a feature ring vertically around a vessel. There, you would cut a rectangle, bevel those angles there, and then build your feature ring. And I've done that and turned a Southwest style vessel out of that. I'd like to show you one, but I don't have any left. They're a lot of fun to make. Use the segmented turning to teach you how to make the segment. Use what you know about these stars to get the size you need, and then convert that into information about your laminated board. You've got it made. You can make any of those. You can also add bands to your stars. If I take 2 different colored bands and insert that between the star and the border material, I'll come up with a banded star like this. and I just make these symmetrical. Now if I need to calculate a size, I normally consider this the radius of the star, and this will be W that I calculate. So the width of the bands is part of the width of that variable called W. We can continue this idea. Here I have Purple Heart, Oak, and Purple Heart, but the idea is that I can completely fill that star with bands of different colors and different widths and generate effects that might be pleasing. This star looks interesting, but it's actually quite easy to make. If I keep this a dark material, keep the border material light, and make this a light material, and put a dark band in between each, then I come up with this. And on my first cut, I get a light material, and on my second cut, I get a dark material, and I just walk around this star. And of course, the border in between, we'll draw this part. That's one way to make this star. Another way is to make it in two blanks. So I'll get 5 segments from this blank and 5 segments from this blank. These blanks are made identically except for the species of the outer boards. So here I have an outer board and a band, and that band runs through both boards. This laminated board gives me this. This laminated board gives me this. Also interesting, if I make a star out of this board, just cut 10 segments out of here, I will get this unit repeated 10 times. So I will have a solid colored plate with a simple black line drawn into a 5-pointed star. Okay. If I go back to this idea, I can make a star, and I don't worry about the details of the size. Around that star, I put a segmented band of dark wood. So just on top of this, I would have a segmented band of dark wood. Then I add to that the standard segmented layers, terminate that in a dark layer, and this is what I end up with. I get a star bowl with the stars encircled by a dark band. Last thing I'll show you is you can take an interesting wood turning, in this case a heart-shaped bowl, drill a hole in it, design a star to fit inside that hole, and come up with something truly unique. If you understand the relationship between this laminated board and this star, and the fact that the center line of this center board is the outer edge of the star blank, and the outer edge of the laminated board is the center of the star, then you can add embellishments to this that combine features of bands, color, and then you take those blanks with the embellishments and turn them into objects that are truly unique. I hope this has inspired you to make a few stars and see if you enjoy it. And I hope I've given you all the information you need to design the stars in the way that you like.